We're now going to shift our focus to look at intervals. So we're going to look at two different intervals in this area. We're going to first talk about a confidence interval, which are things that we've seen before, and then we're also going to talk about a prediction interval. Now, the biggest difference between a confidence interval and a prediction interval is the goal of what you're trying to put that interval on. The goal for a confidence interval is to put an interval on the mean response, versus a prediction interval's goal is looking at an individual response. So an example of what I'm talking about here. Suppose we are trying to look at final exam score, and that's our response variable that we're interested in. As the professor, I'm probably going to be very interested in what the mean final exam score is going to be. So I would want to do a confidence interval. You instead would probably care about, well, how am I going to score? So you're not interested in all the other students and looking at the mean final exam score. You want to know about your individual final exam score. So you would be more interested in a prediction interval. So a confidence interval is focused on the mean of all, where a prediction interval is focused on an individual. So that's just first the difference between those two intervals. Now you have seen a confidence interval before, and you've seen a confidence interval for a mean before as well. But it's going to look a little bit different here because it's going to be for a given value of the explanatory variable. What I mean by that is if there is a relationship between x and y, whatever value x we have is going to actually impact what we'd expect y to be. We would expect the mean price of houses that are 1,000 square feet to be quite different than the mean price of houses that are 2,000 square feet. So we want to take this extra piece of information, the explanatory variable, into account when we do the interval. But the interpretation is going to look very similar to what we've seen before. We're not going to actually do any of the math attached to these intervals. We will only focus on the interpretations of them. So this one will look like I am blank % confident that the mean value of y, or the mean y, which we will put into context when we actually do a problem, will be between the two values that we have, but then taking into account when x equals blank. So taking into account, well, how many square feet are those houses that we're talking about. A prediction interval's interpretation is going to look similar, except for it's no longer interested in the mean. And we're going to phrase it a tad bit different so it stands out. So I'm going to say that I can predict with whatever % confidence that y, notice I'm not putting the word mean there, will be between my two values, and again when x equals whatever value we're talking about. So a lot of this begins to make more sense as we dive into doing an example. So we're going to do two different intervals. We're going to focus on 300 yards and 350 yards. So let's first go to StatCrunch to show you how I got these values. So I brought our data set up here. I'm going to go to the same place that we went to when we got our slope and intercept. So I'm going to put those x and y's in as we did before. Now where I'm going to change things is where it says this prediction of y. So here's where I'm going to put in those different values of x that I wanted. So I wanted 300, and I'll put a comma, and the 350. Then I'm hitting compute and I get the same information that we had before, but I now have these additional values down here that I've just put here for us. So here's the two different values of x, the 300 and the 350. This pred y that you see, that's just y hat. So what would happen when we plug this value into our actual equation? So if we took the 300 times the 0.0969 minus that 9.81 number. So just what actual value would we get? Then we'll have the confidence interval and the prediction interval. So it automatically will do both. So one of our goals, we figure out which one do we need. So here's our first one. We want to find the mean number of points scored in all games with 300 total yards. A couple key things here for me. This one does actually say the word mean, but more specifically and more importantly, it actually uses the word all, right? I'm not interested in just an individual. So I'm going to be interested in the confidence interval for this one. So that's with 300 yards. I want the confidence interval. So I'm going to be interested in that first value here. Now for the second one, we're looking at a game. Right, it has a game. So for that reason, we're going to be interested in the prediction interval for the 350-yard game. So now I just need to focus on interpreting. So let's focus on interpreting this confidence interval first. So I can say that I am, and it says it's 95% confident that the mean points scored in all games with 300 total yards is between, and now let's look at these numbers. Now we are talking about the mean of all games. So the mean can be a decimal. So I do not need to worry about these numbers having decimals. That's perfectly okay. So the mean number of points will be between 15.51 and 23.01. Now let's move to our prediction interval for that 350-yard game. So I then can predict with 95% confidence that the team will score between. Now if I look at these numbers, we are talking about a single game, so it does not make sense to have a decimal here because I can't do that. And we are actually going to extend this into both directions. So we're going to say between 4 and 44 points in a game with 350 total yards. Now, one thing you'll notice about these prediction intervals compared to a confidence interval is that the prediction intervals will be wider. It is harder to capture an individual point than it is to capture the mean of all points. In addition, for this one up here, we could still actually do the prediction interval. I know it does not make sense to have a negative number of points scored, so we would actually just chop that at 0. So if I were going to do this one, I would just change that to be 0. So that still would be okay. So when should I actually not interpret one of these intervals? Well, that's where we want to talk about, well, what numbers would make sense for total yards in a game? So let's look at this through this last question. Would it make sense to use this model to predict a number of points scored in a game with 800 total yards? Why or why not? Or in a sense, I'm looking at taking my equation here, and could I plug in 800? Well, could you have 800 total yards in a game? I mean, it's possible. It's probably not very likely to happen, but it's possible. And I would get a positive number, so it would seem like maybe I could plug it in. But then let's look at our data here. I'm going to look at my scatter plot. Well, where is 800 total yards? Well, it's kind of way over here. I don't have any data there. So it really doesn't make sense to use this model to predict what's going to happen when I have no clue what's going to happen out here. So as an answer to my question of what I want to use this model, my answer would be no, because I don't have data near that yardage. So I don't have any games in my data set with close to this yardage. Now, would I maybe feel okay with plugging in 700? I mean, maybe, because it's not too far outside of where I have data. It's sort of the idea of thinking about trying to predict sales at a company. I could probably predict sales the next couple years relatively accurately, but if I want to predict sales for 30 years down the road, I'm not going to be doing a very good job of that. So we only want to plug values into our model that makes sense. So even though I could go in here and change this and actually plug in 800, like it's going to let me, I need to be the one that knows that I shouldn't be doing that. That it doesn't make sense for my model to do that. Right, the next thing we're going to start talking about is correlation in the next video.